Okay, everybody, let's start in. Today I want to talk about green building and the opportunity to also think about the laws that surround green building and also the energy implications of green building standards. And I'd like to also address the history by having you think about the way that these standards have evolved over time, particularly the evolution of certification programs. So the idea of certification, I want you to think about it quite broadly at the outset because it basically implies that certain standards are being applied to something. It might be a product, it could be a service, it could be a neighborhood, a city, so that the idea that there is an expert group that would review something, whether or not it's your academic preparation and performance or whether or not it's a building's performance, and then certify it and give it a symbol. It would rank it relative to others. One obvious example would be looking at a GPA and a transcript. Well, what we'll see after today's lecture is that the green building programs that have evolved in Europe, in the United States, and Australia, they really are based on that same kind of concept. So how would you rate the environmental and health responsibility and energy efficiency of new building standards? How would they apply, or how might they apply to renovation projects? So I'm basically going to use the lecture today to share with you an overview of a paper that will be published in about 2 weeks that is a critique of the U.S. Green Building Council's program known as LEED. So I'd like you also to think about the importance of the building sector in its demand for energy in the United States. Buildings consume 76% of the U.S. electricity and emit almost half of the nation's greenhouse gases. So that how we manage the future of building and development will very much influence the intensity of energy demand. Keep in mind also that the U.S. consumes more energy than any other country in the world, and U.S. consumes nearly 25% of the world's energy and only accounts for 5% of the world's population, so that our energy demand is increasing at about 2% per year. So why might that be? I mean, obviously we're changing our behavior, we're changing our technology and our dependence on technology, and also the environments that we shape around us have enormous implications for energy that often are not well understood for a variety of reasons. You, for example, probably have no understanding of how your daily behavior and variability in your behavior might influence your daily energy demand. The way that you manage your computers, the way that you manage your windows, your air exchange between indoor and outdoor environments, the way you manage lights, whether or not you have a car on campus. If you do, how often you use it, where do you park it, what's its fuel efficiency. So thinking about how to keep track of an individual's energy demand is really not in most people's minds clearly defined. So as I just said, the contribution to the climate change problem and our dependence on foreign oil is really very much dependent upon the way that we build and the way that we set up standards to encourage energy efficiency. So 39% of CO2 emissions come from the building sector, 40% of energy consumption, total energy consumption, 13% of water consumption, and about 15% of the gross domestic product per year is associated with the building sector. Think about the different patterns of growth and how the different patterns of growth and neighborhood development influence the way that we use energy. These houses are not connected, so they can't gain any benefit for heat conservation by having joining walls. They all have their own yards. And in fact, if you think about how people move around in these kinds of neighborhoods, you'd realize that because of the fencing in the backyard and without gates that go between all the different lots, and it would be quite normal for somebody to get in a car and then drive all the way around the block to take their kids to somebody else's house that might be less than a baseball throw away. So that patterns of development encourage patterns of transit that have just an enormous influence on the way that we consume electricity, but also petroleum products. So think also about the cities in the nation that during the 1990s and over the past decade have experienced some of the most rapid rates of growth. Well, these include Las Vegas. And Las Vegas is expanding into the desert in a manner and at a density that is suburban, it's sprawling, but it's unusual in Las Vegas because of the arid environment, so that every house would likely have a lawn. The lawn would require sprinkling. Many of these houses also, once they're built out, would have swimming pools. So that think about the way that the use of water demands energy to not just move it around, not just the distribution, but also filtration, and also the energy that goes into putting in the infrastructure to move it around. Now, on Thursday, I'm going to come back and talk more about the Newtown movement in the United States and this problem of managing growth at a larger scale than today's lecture, which is really focused on the building, individual buildings. But it is interesting that a movement evolved in the 1960s and 1970s in the United States to design neighborhoods, to design whole new communities in a way that would take into account some of these problems. Irvine, California is the example in this slide. And you can see the center of the campus, but you can also see the large academic buildings surrounding a green in the center. And then in the adjacent areas you have recreational facilities, but also higher density housing nearby. It's a very walkable community, one that is not based on the idea of segregating land uses, commercial versus residential versus industrial versus recreational. So that in suburban Connecticut, you put your kids in a car and you drive from the area where you live to where you work, to the recreational area, to dance lessons, whatever it is. So that this community was intentionally designed back in the 60s and 70s in a way that would provide for mixed land uses and offer opportunities for much increased pedestrian traffic. As opposed to suburban areas around New Haven, here's an example of a community about 20 miles away that many of my colleagues live in. And this is zoning at a scale of about 1 unit per 4 to 5 acres. So each of these houses has a strip of land that reaches back from it into an area that might otherwise be a common open space. So that this low-density development demands even more time spent in cars and more fuel. A good example of a house in a more rural part of Connecticut. So that keep these things in mind as you're thinking about your own behavior, the way you grew up, and you try to consider how your lifestyle choices influenced your family's consumption level. Also, I want you to think about the idea of size and how we are increasingly dependent upon many consumer products in our lives that are larger than they used to be, and housing is no exception. So that the average house size in 2009 is grown to about 2,500 square feet, with about 2.3 on average people per house. So that's really pretty remarkable. So, roughly 1,000 square feet per person, whereas back in 1950, the average number of people in a house was about much closer to 3, a little bit over 3, with a post-World War II baby boom, with a total size of 800 square feet. So the house size has grown by threefold. In 1970, it grew to 1,500 feet. So the energy demands of a larger house like that are actually quite difficult to predict if you try to take into account the diversity of building materials. Boy, I apologize for this, and one of you might go outside and let them know that there's a lecture going on in here. That would be really nice. The construction is it's creating also diesel fumes inside the building. Many of the garages that you find in suburban areas also have grown in size. So here's an example of a garage that is actually larger than the average house size was back in 1950. This is probably about a 22, 23 by 30-foot house, so that's roughly 1,200 square feet. Pretty interesting. And think about the way that space is laid out. So here's a studio apartment on the right-hand side, and you see a dining table, a kitchenette, walk-in closet, and a bath on the upper level, whereas the base level is dominated by a garage. So that we're allocating less space indoors to our bedrooms than we are to our auto storage areas. Also, many buildings are now constructed with much more glass in them than previously. And the newer high-end buildings are using special glass that is designed to reflect radiation so that it's not absorbed. But different glasses are really designed for different climatic regions so that some are more efficient at reflecting radiation that are used in southern climates that are warmer, and others are more efficient at providing insulation. So they've got a barrier in the interior that basically protects against heat loss. So that overall, though, buildings' increased use of windows has created increased energy demands. Also lighting, and also the way that we have increasingly designed bathrooms to have more than one fixture. So here's an example of a shower stall that has multiple shower heads in it, multiple faucets, so that water demand is often increased in bathrooms designed like this. Most green building programs also attempt to regulate the building materials that are used in furnishings. So here's an example of a bookcase and set of drawers that seemingly are made out of oak. But this is actually an oak veneer, and if you have been up in Croon Hall, where the Forestry and Environmental Studies School is, you may know that about 70% of the wood that's on the interior of this was grown on Yale property, on Yale forests. It also is red oak, but it's solid red oak. It's not a veneer. So what's beneath the veneer? Here you can see a strip of press board that is faced with a white oak surface, but the interior is basically low-grade wood chips of a variety of different species that are compressed together, and they are mixed up in liquid form with adhesives, and then they are rolled out on a strip and then cut into a variety of different sizes. The adhesives have compounds that are often proprietary and even unknown to most who purchase them or sell them at building supply houses. They commonly contain adhesives that are epoxy resins, some of which contain bisphenol A that we talked about earlier in the course, but also formaldehyde is a component that is commonly used, that is an allergen, and it's a suspected carcinogen. I'd like you to think too about the problem of your understanding. How could you increase your understanding of the energy intensity of your own lifestyle? Well, here's a pretty good example of the way that houses that were built in the 1990s and previously are metered. So that this is at your utility junction box where the line comes in from the road. This is my meter. I have the same brand. And it's got 5 dials on it. And you might think, well, that's not that tough to figure out. But if you walk up to it, you'll see that the dials actually have the numbers that on the first dial on the left, it goes from lowest to highest in a clockwise motion, but in the second it goes from lowest to the highest in a counterclockwise motion. So they switch on as you move across the screen. So this is actually a very difficult thing to keep track of. Now, also, you might wonder, well, how would I find out, how my variance in behavior, how I manage my computers or my lights or my water consumption or how big a refrigerator I have, how is that going to affect my electric bill? It's really hard to figure it out given this kind of a metering system, because if you can decipher what the meter says, you'll only get a total figure for your consumption. Now, this has created an opportunity for people to design a variety of smart meters that keep track of energy intake and use and how it's distributed in a house for different purposes. So that I tried to figure this out given my dial meter at my home, and ended up turning off absolutely everything in the house and then starting up appliances one by one. So I'd start the refrigerator, then I'd turn the refrigerator off. I'd start a dryer, start a dishwasher, but that would be the only appliance that I would have running. So that, but you can imagine, every time you plug in one and then go out to the meter and take a reading, come back in, unplug it and plug in something else, it's going to take you a very long time to figure out where you're spending your money. By doing that over a period of about 8 hours, I was able to save about 25% of my average monthly energy bill by figuring out how to restrict access or fully turn off different appliances in the house. Building products and building construction is normally regulated by a variety of building codes, many of which have been adopted internationally. So that these codes apply to materials, they apply to electrical systems, they apply to energy sources, fire prevention, mechanical heating and ventilation and air conditioning systems, plumbing. They even apply to historical sites, and in earthquake-prone parts of the country, they have a code that is distinctive in California for earthquake stability. So that these codes evolved originally as being voluntary, so that they were not formally adopted by state or local governments, but now you find most states do have similar kinds of building codes. And they were originally designed to promote understanding of the functionality and the safety and the durability of different kinds of products, also to promote truth in labeling, but they never really were designed to promote environmental responsibility, health protection, or energy efficiency. So that the green building movement was really ripe for a brand new certification system that would apply a variety of different kinds of standards. And the three programs that I'll mention today include the LEED program by the U.S. Green Building Council, the BREEAM program in the United Kingdom, and the Green Star program in Australia. And the BRE environmental assessment method is perhaps the best known in the world right now, and it's the most widely adopted throughout Europe. And it sets standards for best practices in sustainable design, and has become really a de facto measure used to describe a building's environmental performance within the European Union. Australia has the Green Star program, which is national. It's also voluntary, that evaluates construction, environmental design, and has been particularly well developed for commercial structures, especially office buildings in downtown districts, where about 11% of the buildings have been constructed and certified under the program. So its purposes are to, first of all, try to figure out a common language and common definition for what green is, so that before the National Organic Food Standard was adopted, there was no national consistency in the definition of what organic food was. So it varied by certification scheme. It also, the Green Star program also sets measurement standards, so that there is a common approach to measuring, say, energy consumption or the capacity of different building materials such as electrical conduit. And they also promoted a whole building design, so that one would think about not just the individual components, the individual building materials, or the different systems. And by systems, I mean like water supply, electrical supply, perhaps the heating and ventilation system or plumbing, but to figure out how to put all of these components together in a way that would minimize the long-term adverse effect on environmental quality or human health or energy loss. So this idea that one would think about building materials and the style of design in a way that would consider the ultimate product life cycle, this is really a pretty new idea in the building industry. So that, you know, what's going to happen to that PVC pipe that exists in your house when your building gets torn down? What's going to happen to the copper piping that delivers the water? Well, the PVC pipe, you can almost be assured is going to be either burned or it's going to be discarded in a landfill, but the copper piping is highly likely to be recycled because of its market value. So differences in these programs are normally associated with the way that they allocate credits or points to buildings for different purposes, but they really are quite similar in their attempt to promote energy conservation, concern for chemical life cycles, as well as human health. So the Green Building Council evolved beginning in 1993, and this is what I want to focus on now for the remainder of the session. And it is a voluntary, nonprofit organization that has no government affiliation, although it was started by a grant from the U.S. Energy Department. So this is created with a board of directors that include people that have expertise in architecture and engineering, as well as some of the largest development firms, construction firms in the nation. There are really not a number of people on this board or on the staff that have deep environmental or health expertise, and its orientation is predominantly been to promote energy efficiency. They claim that the benefits of this leadership in energy and environmental design, which is what the LEED acronym stands for, that it has three predominant purposes. One is to promote environmental quality. The second is economic development, to basically stimulate a new type of building and new building materials that are more environmentally responsible. Sorry about the noise. And also to promote healthy lifestyles within buildings and communities. And by healthy lifestyles within a building, I'll give you one example. A colleague of mine works at the Centers for Disease Control in Atlanta, and they have a relatively new building. And just as a healthy lifestyle they decided that instead of putting a staircase in the back of the building and the elevator right near the front door when people walked in, that they would reverse that. So the elevator was put in the back and the staircase was surrounded by glass panels that made it really light, sunlight streams through and attractive, so that people, when they go into the building, normally walk up the stairs, a 7 or 8 story building. So that this individual who directed the National Center for Environmental Health told me that he and his staff, that nobody uses the elevator. Everybody goes up and down the stairs, so that it burns, it saves energy. The elevator's not used much, and also it also is healthy. It's burning up calories. So that the purpose of LEED falls into a variety of categories. One is sustainable sites, another is water efficiency, another is energy and atmosphere, another is materials and resources, the fifth is indoor environmental quality, and the fourth is really creativity and innovation in design. So, I mean, you might imagine different categories might be a part of a system such as this, but there are interesting questions about the relative importance that these categories should be assigned. Should you be assigned as much about the nature of the site that's chosen for building, whether or not it's remote and is going to be in a greenfield area, as opposed to the site that might be hazardous and contaminated, so that the Croon Hall up on Prospect Street across from the Whale, the Croon Hall was built on a highly contaminated site, so that a former power plant was there, and a lot of work had to be done to clean that site up, to remove contaminated debris, as well as other infrastructure, the heating and electrical and hot air conduits that go from the power plant up to Science Hill, particularly Klein Science Tower. So that the idea that you would give more credits to a building program that would not chew up undisturbed areas that are in, say, the suburbs, you'd give more credit to those that were actively going to restore sites is an interesting concept. The certification program that I'm going to talk about today has to do with new construction and renovation, although there are other programs that LEED has. For example, a program for schools, a program for homes. So that in this program, there are 100 base points plus 10 possible bonus points. And there are different levels of certification that can be achieved. So if you achieve 40 to 49 points, you are certified. Up to 50 to 59 points, you're given a silver certification. Gold is 60 to 79, and then platinum is 80 to 110 points. You could imagine a variety of different strategies here that would hold the bar higher for the base level of certification, or perhaps hold the bar higher for only the platinum level. The Kroon building was just certified to be a platinum building as an example. So these are the different kinds of certification programs that LEED has beneath its umbrella. And as I mentioned, the first one, new construction and renovation, is the subject of today's talk, but also schools, core and shell components of buildings, neighborhood development, retail facilities, healthcare facilities, commercial interiors, and homes. Sorry, I've got a couple of duplicate slides here. So I'd like you to think about sustainable sites. Credits can be awarded for building on previously developed land. They give additional credits for minimizing impacts on ecosystems and waterways, for promoting landscaping that is regionally appropriate. So, for example, in the slide that I showed in Arizona, if you were trying to get LEED certification for a new project, you would need to be very careful about the kind of landscaping that you put in, making certain that it wasn't water dependent. Whether or not the building site encourages access to public transportation, so proximity, say, to a rail station would improve the number of points. The control of stormwater runoff and erosion, so as an example there, Kroon Hall has a very large gutter that overhangs the south side and funnels water down into that water garden that is on the eastern side of the structure. And then that water moves through a filtration plant inside the building and then is recycled into gray water so that it is used for removal of human waste in the bathrooms. Also, here's an example of how that building achieves certain points by the restoration program, digging out the old contaminated lands and rebuilding. So for each of these categories, I'm not going to spend much time on this, but for each of the categories, you can achieve points in different directions. And you can imagine that the way that these points are allocated category by category could have a pretty significant implication for providing encouragement. By the way, why would a developer want to be LEED certified anyway? You know, what's the value? Well, I mean, I mentioned one value that would be to the building industry at large, but which is creating an incentive for a new line of products and a new approach to building design that would create jobs and cause the industry to grow generally. But most developers are in this because they know that if they achieve certification, then the property value is higher. They can demand a premium for the structure or the complex. So that in this case, the sustainable sites category allows one to seek about 23% of the total number of credits that are possible. So that these can be awarded for brownfield redevelopment, for alternative transportation, the bike storage area that you find behind Osborne Laboratory caused FES to gain additional points. The management of stormwater, trying to manage a heat island effect, reduce that intensity of heat absorption by creating green roofs. They also, there's a green roof that's on part of that site. Water efficiency also is a source of possible points, about 9% of the total. And so that within this category, appliance efficiency, fixtures and fittings are good examples of different ways of saving water, as well as the landscaping that I mentioned earlier. I wanted to mention a couple of kind of relatively recent technological designs One is these leverless faucets that sense your presence either by an electronic eye or sensing heat that causes them to turn on and off. And it's kind of interesting. I've become more curious about this and watch people's hand washing behavior, particularly in places like airports. And it's really common to have a whole array of these things on a countertop, and people often have to move from one to the other to get one to work. And after that happens a number of times, people, I think, are more likely just to not wash their hands. So there's a sanitation problem that is potentially associated with it. If you go into the men's rooms and look at the flushless urinals, you'll immediately recognize that there is a serious problem in Kroon. And it's led many to argue that they really would rather make the trade-off between the odor in the bathroom and that might otherwise be managed by improving the heating and ventilation system. So that right now, no water is used in this toilet. Only a synthetic compound is put in to try to maintain its sanitation, but it often is not as effective as it is promoted to be. So that water efficiency can be achieved in a variety of ways. The faucets themselves are often fitted with restrictions in flow, so that the need to, if you're interested in taking a more powerful shower, you'll need to figure out how to get the flow restrictor out, which many people do try. The flow restrictor itself is governed by local and state building codes, and it was kind of interesting to me. It was an education for me when I wondered. I asked a plumber who was installing a new faucet in my sink, and I said, I really would like a larger rate of flow in this sink so that I could be more effective in washing dishes or whatever. And he said, well, you really don't understand the energy implications of not restricting the flow. And if you thought about it, then you'd realize that the energy costs are really quite high to move the water to your home. I said, well, I've got my own well. He said, well, think about where the energy is coming from that causes your pump to lift the water 600 feet. And then also think about the more water that you use, the more waste you create, so you're likely to disperse biological and chemical contaminants more broadly. So my plumber gave me a lesson in environmental behavior that I thought was quite valuable. So the majority, not the majority, but the highest proportion of points or credits are awarded under the LEED program for energy and atmospheric concerns, so that new buildings can obtain points by monitoring energy consumption, and this is being pretty carefully done in Kroon Hall as an example. And the orientation of the building at Kroon, it's facing east to west, so that it has more window space on the south side to absorb more solar radiation. It also has solar panels that run across the south side, and a variety of other saving techniques. So that the dominance of energy and energy conservation in the LEED certification and credit program relative to these other categories is quite interesting. With respect to materials and resources, the management of waste is also more intensely monitored within a LEED certified building. And when a building is actually certified, it's not certified for forever. It's certified for a fixed period of time, often only a single year. And a building is not certified until it can demonstrate that it is performed at a level of X during that year. So it's kind of an interesting idea. If a building's heating and ventilation system malfunctions, then a year or two down the road, it's not going to be recertified. Indoor environmental quality is increasingally a concern, and only 15 points compared to about 34 points in the energy category. Only 15 points are allocated for indoor environmental quality. Now, what does that mean? It generally means a concern for the chemical content of the indoor environment. But it also includes the opportunity to gain points for natural daylight and views, and also for acoustical control, noise control, so that the situation that we're experiencing here might be avoided. Now, again, think about the importance of this in terms of human chemical exposure, given the fact that we spend so much time indoors. This diagram is now a couple of years old, but in the latter part of the 1990s, EPA was estimating that about 86–87% of time was spent indoors. About 5% of time was spent in a vehicle. So thinking about the chemical content of the indoor environment is important, especially for certain subgroups like kids. This can be managed in a variety of ways, and you could think, well, the ventilation rate or the air exchange rate, indoor to outdoors, is one way of doing that, depending upon where your building is. So in general, outdoor air quality is better than indoor air quality, unless you live in proximity to an industrial area or to a highway, so that being able to mechanically and individually control windows is an important strategy for managing air quality. But also thinking about a variety of different materials and compounds that are brought into the built environment, so that some compounds and some products are discouraged under this program, so that paints, for example, that emit a high level of volatile organic compounds are discouraged. So low emitting paints, varnishes, polyurethanes are now designated, so that if you look at the can of a oil-based paint, you'll find that roughly 2.5 pounds of volatile organic compounds are contained, whereas certain paints are now manufactured with no volatile organic compounds. You might also think about the compact fluorescents that pose a kind of an interesting problem in that they contain mercury. And so that this is a piece of personal advice for you. As you install or remove compact fluorescents, be really careful about them, because if they break in your room, it's going to scatter mercury around, and the mercury will vaporize. If it gets into a rug and you vacuum the rug is going to give off the mercury vapors, and it will increase the volatilization rate, and it will be just about impossible to completely remove the mercury from the room. So this is a problem associated with the compact fluorescents that is turning into a rather interesting and serious dilemma for waste management. So not many people really want to take an old burned out light bulb back to a recycling center. In fact, the probability of getting it there without breaking it is probably not too great. And also think about, again, plastics in landfill. An increasing proportion of the interior built environment is made up of a variety of plastics that we've talked about in the past. But the extremely low chance that plastics are going to be recycled is a logic to rethink the way that points are allocated. There was an interesting debate inside the Green Building Council about polyvinyl chloride plastics and whether or not PVCs ought to be either banned or whether or not you would have credits removed if you use PVC as opposed to a more recyclable product like polyethylene that the most soda bottles are made out of. But they decided not to do that, which is quite curious. So thinking about the kinds of materials that are put down on floors, the sealants also, this is encouraged. Credits can be gained if you choose not just the low VOC paints, but also the clear finishes. Also, you'll find a variety of products, including this type of a vinyl flooring that you could see in Croon Hall, particularly in the stairwells, that gives off volatile compounds that I haven't been able to identify, and the manufacturers are not required to label. So think about the variety of different products that go into purchasing or go into the construction of a building, and how these products may change the chemical content of that environment, so that the quality of the air exchange system is really critical to govern the chemical exposures that occur, and this is particularly the case in a new building. As an example, rugs. Rugs may be made out of natural products, natural fibers, such as wool or cotton or some, now increasingly some reed material from South America. But rugs that are made out of synthetic compounds and their backing, many are recommending that those be aired out in a warehouse or in a garage for a period of time, up to a couple of weeks before they're installed, so that occupants of new buildings would not be exposed to those fumes. A couple of other examples that are not managed by LEED. Certain golf courses have been certified, whereas the expectation on the part of the Green Building Council is that the chemicals that are used are regulated by the Environmental Protection Agency, and the chemicals that are used on golf courses are commonly quite a complex mixture. As you remember from the pesticide section of the course, many of these have not been fully tested. A variety of insulating materials also can expose workers at levels that are potentially hazardous to their health, so that some acrylics, for example, that play an important role in increasing the energy efficiency of a building, but they can lead to worker exposure situations. So thinking about whether or not LEED should get involved in concern about the production of the chemical and its application and the way that it's actually used to build the building is interesting. LEED has also certified a bottling plant, raising kind of an interesting question. Well, what if, say, DuPont Corporation wanted to build a plant to produce a variety of chemicals that were extremely hazardous, and perhaps they got into water or air or soil? Should they be allowed to get platinum or LEED certification for that structure? Should Nestle be allowed to gain certification for marketing products that are not likely to be recycled? Here's another example of a project that was certified in Florida. And you remember the lecture last week about barrier islands. Well, this owner owns the tract of land slicing across a barrier island from the bay to the shoreline, and obviously has quite intensively developed it. You know, seeing the amount of square footage in homes and the low occupancy rates has led me to wonder about whether or not the government might think about regulating square foot per person or cubic foot per person. I mean, how much space do we really need per person? So I'm going to run through just a few summary of findings here before I close today that should give you a sense of what's working and what's not working too well with the LEED program. These standards have been designed by a voluntary nonprofit organization, but they've been adopted increasingly at all levels of government in law. So they've been added to Connecticut's laws, for example. So Connecticut now requires that new buildings that are going to cost more than $5 million need LEED certification. Many of the Department of Energy's programs are now designed to encourage giving of grants to projects that gain LEED certification or would gain LEED certification. And many local governments are now adopting these standards. So that what's happening here is that the standards are being developed by a voluntary nonprofit organization, really to promote a new form of growth and development. But they're being incorporated wholesale into a variety of different levels of government without really thinking critically about what's working well and what's not. There's now no federal definition of what a green building standard should be. Clearly, this program gives a higher priority to energy efficiency over indoor environmental quality or human health. And if I were going to design a statute that would encourage green building, it would certainly give increased precedence to public health concerns and the chemical content of buildings. The Green Building Council has very little expertise in human health, and that in part explains why these standards are not well developed in that area. Still, the Green Certification Program, the LEED program, gives a false impression of healthy buildings. And tighter buildings are more energy efficient, but tighter buildings also more effectively contain chemicals that get into indoor air. So that no level of certification, even the highest level, the platinum rating, assures health protection. LEED also neglects drinking water, so that drinking water supplies are managed in the nation predominantly by the Safe Drinking Water Act and the maximum contaminant level standards. So there is no requirement under LEED to certify, to filter water. Despite the fact that many water lines are capable of transmitting not just metals, but also some of the components of plastics. So that the core problem with respect to managing chemicals in the indoor environment and the ultimate life cycle of chemicals has to do with Congress's inactivity, its failure to demand that chemicals that are used in the building industry be labeled, that they be tested before they're used, so that it's creating a pattern of exposure that really we don't understand well. We know we're being exposed to a brand new mixture of compounds. So what kinds of recommendations might you think about to improve this system? Well, one would be to simplify the scoring system so that rather than using the platinum, the gold standards, I would prefer to see a scale that was simply a 0 to a 100 scale, so that people would not have the incentive just to get to 80 points, so that would ensure that they would be awarded the platinum certification. I think that the categories of certification need to be diversified, so that if the Green Building Council judged and scored a project's performance in separate categories, developers would have an incentive to score higher in all those categories. In other words, set up a separate scoring system for indoor environmental quality and human health. Set up a separate system for energy efficiency. Set up a separate system for water supply. But whether or not we want to have this system managed by a nonprofit organization that is run by the board of directors that have predominantly for-profit organizations, that's another basic question. So should the federal government take this over? So this system is not designed in its current form to encourage the use of safer chemicals in the building industry. So that what kinds of innovations might encourage builders to want to buy buildings or buy building products that contain safer products? Well, they would certainly need to know what the chemicals were in the products, so that there's a labeling issue that needs to be confronted, but also there's a testing issue as well. The Green Building Council also has the opportunity not to disclose the results of its building performance tests, so that the public really has, excuse me, the public has no opportunity to hold the Green Building Council accountable for its declaration of performance in different categories. So I think I'll close with the thought that this is a very interesting historical example of how certification standards evolved in a nonprofit organization that really is representing for-profit industries, the large building products industry, the major building companies, large architectural firms and engineering firms, and this program has no accountability at all to the United States public at the same time that it's being built into law at all levels of government. So something seems really very much out of whack, and it demands, I think, a pretty careful review. One critical improvement could be made if minimum performance criteria were set within each of the specified categories: sustainable sites, energy, the category for indoor environmental quality, so that if there were minimum and protective standards set inside those categories, it would go a long way to meeting some of the objections I just raised. Okay, thank you very much. We'll come back to larger questions of community design on Thursday.